Hello, everyone, and welcome to our AI in Healthcare conference, The Non-Obvious Solutions. We are thrilled to have you join us today as we explore the transformative impact of artificial intelligence in healthcare. My name is Mikhail, and I'll be the host today, and I'll be moderating this event. We have presentations from leading experts in the field, along with Q&A sessions at the end of each lecture. I hope you find this conference both interesting and useful. Before we begin, I would like to review a few important points. If you have any questions for the lecturer, please type them in the chat. We'll address them during the Q&A session. Also, please write the pluses in the chat if you can hear and see us. Let's quickly go through our agenda for today. The opener is Maxim Khomutskiy, Senior Solutions Architect, Global Healthcare and Life Sciences at Amazon Web Services, who will share how AWS is transforming healthcare with generative AI. Next, we have Andriy Boychuk, AI Technical Leader at blackthorn.ai, who will discuss the latest advancements in medical image processing. Our final speaker, the Alex Grubic, CEO and founder at blackthorn.ai, will explore how innovative technologies like VR Healthcare Studio and LLM-backed AI assistants are transforming healthcare. So without further ado, let's kick off our event. And now I would like to invite our first speaker, Maxim Khomutskiy, the Senior Solutions Architect of Global Healthcare and Life Sciences at Amazon Web Services. Maxim, over to you.
Thank you, and good morning. My name is Max Khomutskiy. I'm a Senior Solution Architect, Global Life Science and Healthcare with Amazon Web Services. Our topic for today is advancing your healthcare mission with generative artificial intelligence. According to McKinsey survey on the adoption of machine learning, almost 60% of the companies reported that they are AI in at least one function in their organizations. And that tells you that ML has transitioned from being something that only a handful of companies used to do, becoming integral to how companies do business today in large part. AWS drove this transformation by building a broadest and deepest set of AI and ML services, over 100,000 customers doing machine learning on AWS today. At AWS, we have played a key role in democratizing machine learning and making it accessible to anyone who wants to use it, helping our healthcare customers innovate faster with access to the most comprehensive set of AI and ML services. When we introduced Amazon SageMaker back in 2017, our goal was to make machine learning more accessible and easier to use to healthcare organizations of all sizes and disciplines. And since then, we have seen rapid acceleration in adoption of AWS machine learning among healthcare organizations, including Philips, Cambia, 3M, and Roche. So, what is AI? AI is the way to describe any system that can replicate tasks that previously required human intelligence. Most AI use cases are looking for probabilistic outcome, making prediction or a decision with a high degree of certainty, similar to human judgment. Almost all AI systems today are created using machine learning. Machine learning uses large amount of data to create and validate decision logic, which is known as a model. Deep learning is type of machine learning that uses a technique known as deep neural networks. These systems replicates how human brains function, which allows those systems to address more complex use cases than was previously possible. Finally, reinforcement learning trains model by using reward function of desired outcome. It's used, for example, for autonomous vehicle and usually requires simulation tools to train model. But what exactly generative AI? AWS has been doing generative AI for years. For example, foundational models are used to generate highly accurate speech results on search results on Amazon.com, and to deliver the human-like conversational experience millions of people enjoying every day with Alexa. And Amazon made state-of-art Alexa teacher model, a large language model available through Amazon SageMaker. Customers can use this LLM for a wide range of the use cases, from summarizing financial reports to powering human-like customer service chatbots. Generative AI is on the rise because it can produce new original content that is close enough to human-generated content for real-world tasks such as questions answering, text summarization, and image generation. The ML models powering generative AI, popularly known as foundational models or large language models, are trained on a massive amounts of data with several hundred billion parameters. There are many existing successful applications that rely on LLMs. For example, AI-21 word tune write which millions write more easily using AI-21. Jurassic model, ChatGPT, which utilizing a customized version of OpenAI GPT 3.5. Amazon Code Whisper that accelerate application development with automatic code recommendations based on code comments in your IDE, which uses an Amazon LLM that trained on a code dataset. We see many enterprise customers that won't harness the same foundational models to their business use cases. Developers can adapt the models for a wide range of use cases with little fine-tuning required for each task. For example, Stable Diffusion, the foundational model from Stability AI, is used by hundreds of applications such as Dream Studio and Photoshop, reaching millions of end users. In this way, power of these capabilities is accessible to all, including developers who lack of specialized machine learning skills, and in some cases, people with no technical background. Using foundational models can also reduce the time for developing new AI applications to a level rarely possible before. The size and general purpose nature of foundational models make them different from traditional machine learning models, which typically perform specific tasks like analyzing text for a sentiment, classifying images, or forecasting trends. With traditional models, in order to achieve each specific task, customers need to gather labeled data, train model, and deploy that model. With foundational models, instead of gathering labeled data for each model and training multiple models, customer can use the same pre-trained foundational model to adapt various tasks. Foundational models can also customize to perform domain-specific functions that are differentiated to their business using only small fraction of the data and compute required to train model from scratch. The potential of foundational models is incredibly exciting, but we're still in very early days. AWS Generative AI Stack includes 3 macro layers, and they are all equally important. We're investing in all of them. The bottom layer is the infrastructure used to train foundational models and run these models in production. The middle layer provides access to all LLMs and other foundational models you need to the tools needed to build and scale generative AI applications with them. The top layer, we have applications built leveraging foundational models so that you can take advantages of Gen AI quickly without any specialized knowledge. Foundational models use cases are generate new pieces of original content, such as short stories, essays, song, creative art, jokes, images, by providing generative AI models with specific prompts of them. Accelerate application development with automatic code recommendations based on the code and comments in your IDE tools. Get brief summary of textual content such as article, meeting, blog post, book, documents to get gist without having to read the full content. As writing assistant, by rephrasing the text, you write to perfect grammar or rephrase the message in particular tone, let's say casual or professional. Make it shorter or longer. Accelerate writing with skeleton generation. For example, to create onboarding form for customers interested in joining a product beta program. I could simply ask the model to create a skeleton form and then apply any changes to fit exact what I need. I could even get a more specific results by asking that the form will include customer contact details, demography, and industry. Building conversational interfaces, such as chatbots and virtual assistants to enhance the user experience for your customer. Search and find and synthesize information to answer the questions from the large corpus of data such as the internet. Run image classification, correctly flag product brand and category for, let's say, 1 million SKUs. Use cases with image generations also can create novel design for your peer products using pre-trained models with a fine-tuning. GenAI can support clinicians' workflow by listening to patient conversation, summarizing clinical notes, and consolidating the records from various sources into EHR. It can also suggest optimal imaging and diagnosis based on the patient data. For a care management system, can efficiently review records of registries, analyze individual records to identify risks, study cohorts in the EHR to reveal population risk and segment groups for a targeting intervention. To improve patient engagement, GenAI can provide self-triage capabilities, productively communicate with patients, offer post-discharge care guidance, and generate patient-friendly reports. GenAI can boost research efforts by automating data cleaning and enabling cross-patient queries to identify clinical trial matches. Finally, for enterprise functions, chatbots can serve educational needs for medical students while also helping search documents and field IT, HR, and other internal questions. AWS customers have asked how they can quickly take advantage of what is out there today to quickly begin using foundational models and generative AI within their business and organizations, drive new levels of productivity, transform their offerings. We identify 4 important considerations: quickly build and deploy generative applications at scale. Amazon Bedrock is fully managed service that make range of powerful foundation models from Amazon and leading AI companies, including AI21 Labs, Anthropic, Cohere, Meta, and Stability AI, available through the scalable, reliable, and secure API. With Bedrock serverless experience, you can quickly experiment with foundational models, privately customize foundational models with your own data, and easily integrate and deploy them into your application using familiar AWS tools and capabilities without managing infrastructure. Agents for Amazon Bedrock make it easier to develop it for developers to create generative AI-based applications that can complete complex tasks and respond with more accurate and relevant answers using retrieval augmented generation. We believe in offering the best choice and flexibility on foundational models for your use cases. We have our own Amazon Titan model, including Titan Text for text summarization and our Titan Embeddings model for embeddings and search. We offer AI21 Labs Jurassic 2, which use natural language to generate text in a variety of languages. Anthropic Cloud is built with the latest research on responsible AI to perform conversational and text processing tasks. Also, now available Claude 3. Comment. But here's a large language model is text generation model trained for business applications such as summarization, copywriting, dialogue extraction, and question answering. Fine-tuned version of Llama 2 models from Meta are ideal for dialogue use cases. Bedrock also supports Stability AI foundational models, including widely popular Stable Diffusion model, which is capable of generating unique images and art and designs. But you evidently need to make sure that all your data is kept privately and secure, that none of your data is used to train the underlying model, that all data is encrypted and does not leave your virtual private cloud. When the customers want to customize the base foundational models with Amazon Bedrock, their customer-specific data is used to train a separate copy of the base foundational model. This customized foundational model is private to the customer, not that neither the customized foundational models nor the data that was used to customize the base foundational models get shared with any other customer. We believe that this should be easier for developers to do. That's why I recently announced the preview of Agents Amazon Bedrock, a new capability for developers to enable generative AI application to complete tasks in just a few clicks. With a few clicks, Agent Bedrock configures your foundational model, automatically break down and orchestrate tasks without any manual code. The agent securely connects to your company's data sources through the simple API, automatically converts your data into machine-readable format, and augmented the user's request with relevant information, generate a more accurate response. Agent in Bedrock also takes action to fulfill the user's request by executing API calls on your behalf. And you don't have to worry about complex system integration and infrastructure provisioning. As a full managed service, Agent for Bedrock takes care of all of this for you. Agents for Amazon Bedrock is currently in preview and will allow you to complete the task in generative AI application with just a few clicks. Talking about the vector databases. We actually announced and supporting right now vector engine for Amazon OpenSearch serverless. And again, this is not the single vector engine that proposed by AWS. This vector engine offers simple, scalable, high-performing vector storage and search without the need to manage infrastructure. Developers can store vectors alongside business data and text, making it easier to query embeddings, metadata, perform text search from a single API call. And because it's serverless, developers don't need to manage cluster or worry about the production scale. In addition to semantic search, embeddings can use to augment your prompts for more accurate results through RAG. As we saw with agents example, we have been investing the most price-performed infrastructure for machine learning, so you can rely on scale with foundational models. Over the last 5 years, AWS has been investing in our own silicon to push the envelope on performance, price performance for demanding workloads like machine learning, training, and inference. And our AWS Trainium and AWS Inferentia chips offer the lowest cost for training models and running Inferentia in the cloud. This ability to maximize performance and control cost by choosing the optimal machine learning infrastructure is why leading AI startups like AI21 Labs, Anthropic, Here, Grammarly, Hugging Face, Runway, and Stability AI runs on AWS. Another important piece is responsible AI. Amazon supports the idea of responsible AI. And we have a principles: treat all people fairly, include everyone, perform reliable and safely, respect privacy and security, explain system openly and honestly, take responsibility for impacts. And I do have a short demo. So this is a short demo how large language model can be used as a virtual assistant. Health systems produce petabytes of unstructured data every day, and it's growing exponentially. This mass of information comprises clinical documents, scanned documents like PDF, laboratory reports, radiology, pathology, image reports, clinical procedures, forms, and tables. This data is not easy to use or analyze. At the moment, 97% of it goes unused since it's unstructured. Every healthcare provider, payer, and life science company is trying to solve the problem of structuring this data so they can operate more efficiently, improve patient outcome, and accelerate decision-making. With Amazon TextRact, you can automatically extract printed text from insurance claims forms and handwritten medical notes and documents. With Amazon Comprehend Medical, a natural language processing service, you can then map each extracted piece of the information to associated medical code with high accuracy and low latency, like RX norm or medications and their brand names, or ICD-10 codes with diseases and conditions. With Amazon Health Lake, an analytics service, you can store, query, and analyze health data for a complete view of patients' medical history. Top use cases for medical IDP include accelerating insurance claim processing, automate claim capture, validation, and approval for workflows for healthcare insurance companies for risk adjustments. So that is to appropriate compensate health plans for the cost of associated with taking on members with chronic health conditions. Scale and accelerate pharmacovigilance, rapidly identify adverse, often reported forms or PDF files to improve drug safety and meet regulatory conditions. Improving population health. Now you have all these indexes and structured data. You can identify health trends in population or realize operational efficiency. I wanted to bring one of the examples. Health insurance companies spend millions of dollars to extract medical information like treatments and procedures from claims forms, coming with attachments, perform their business operations. It used to take an average of 20 minutes per claim to manually extract this information. Anthem choose Amazon TextRact and Comprehend Medical to extract and digitize data quickly, processing thousands of claims each day. It turned their automate 80% of its benefits program claim processing workflow. Here's an example of application architecture that is using TextRact to extract printed forms or handwritten medical notes and documents. And after that, through the chatbot powered by Bedrock and RAC, your user can actually query the information about specific patient. I wanted to touch HealthScribe. With HealthScribe, healthcare software vendors can create applications that reduce burden of clinical documentation. It supports the responsible use of AI by including reference to original patient transcripts for every sentence in AI-generated clinical notes. That makes it easier to validate accuracy of the summary of their application. Security and privacy features are also built in to ensure input audio and output text are not stored in HealthScribe. HealthScribe requires existing infrastructure for a capture patient-physician audio files, and it's still, and again, you can start using it. With this service, you can reduce documentation burden on the clinicians by empowering them to quickly validate and edit AI-generated clinical notes by finalizing their documentation. You can boost efficiency of medical scribers, which can help reduce documentation turnaround time and help you serve more physicians with existing scribe workforces. You can also create an experience that enables patients to quickly recollect the key highlights of their conversation in your application. AWS Health Scribe can be assembled, integrated into your application to significantly enhance and accelerate the clinical documentation process for a clinician. It can provide clinicians with detailed consultation transcripts along with the speaker rules. You can provide the ability clinicians to skip small talk and focus on a key portion of discussion. You can also provide preliminary draft of clinical notes using generative AI, which links back to relevant dialogues in consulting transcript. And you can also extract the key medical terms from the discussion in your application. I wanted to spend a few minutes and cover how you can engage with AWS if you are interested. And again, we have a product which is GenAI Incubator. The GenAI Incubator is a product incubator helping AWS customers accelerate AI/ML adoption and drive into production, where global teams of applied scientists, business consultants, ML strategists, engineers, and architects with deep experience applying machine learning to solve diverse business problems. The team works on hands-on machine learning projects that requires custom solutions to address well-defined business problems with production goals. Again, how we can help? Explore and experiment safely, reliable and cost-effectively. Discover and implement guardrails to reduce the risk. More controls focus across bias and fairness, privacy and security. And governance for enterprise content and workflows. We can help you with selection of the best foundational models. Also, we can apply foundational models to your real-world data and verify how it works. And again, we will help you to balance efficiency, scalability, and risk. In addition to our broader library of digital courses on AWS Skill Builder, as well as programs like AWS Academy, Restart, and Educate, you always can contact AWS for additional guidance. Amazon aims to provide a free AI skill training to 2 million people by 2025 with its new AI-ready commitment. Again, please feel free to visit aboutamazon.com/news/AWS, AWS-free-AI-skills-training-courses. And a couple of the notes, what is needed to succeed? And again, our recommendations start with identifying the most valuable strategic use case that will benefit from AI capabilities. Focus first on the potential impact rather than on technology. Evaluate your current data assets. Confirm you have the resources and methods needed for responsible data use. Access your internal capabilities. Leverage trusted partner if needed. AWS offers an extensive partner network and professional services to accelerate your AI initiatives. Start small with 1 or 2 proof of concepts. Iterate based on the learnings. Scale will demonstrate clear value. We offer industry's most comprehensive set of data and machine learning services designed for optimal price performance for any use cases. We're investing in zero ETL future so you can quickly and easily connect all your data. We provide end-to-end governance capabilities to help you move faster with data. Our offerings are proven in some of the most demanding usage scenarios. We have more than 1.5 million customers using AWS databases, analytics, or machine learning services. We have 17 years of data and machine learning innovation and continuing with many industries first, starting with Amazon S3. We're first scalable object storage in the cloud and our first generally available AWS service. And we'll offer multiple ways to get started, including trainings, enablement, and global network of 1,000 partners, independent software vendors. Thank you all, and have a wonderful rest of your day.
Thank you, Maxim, for the excellent presentation. Don't forget that by attending today, you'll have the opportunity to benefit from the exclusive offer, including a 10% discount on creating your own AI product and a free AI integration readiness checklist. To get it, you have to go to blackthorn.ai/contact, fill in the form with your goals, and add the promo code AI10. Next, we have an exciting topic lined up for you. Our second speaker, who will join us just about in a minute, is Andriy Boychuk, AI technical leader at Blackthorn.ai. Andriy will be sharing his expertise on how AI can enhance medical image processing, bringing about cost reduction, process optimization, unbiased AI diagnosis, and much more.
Hello, everyone. I hope you can hear me just fine. So before we start, let me just answer a few questions I saw in the chat before the talk. I saw some questions about sharing the previous presentation. Unfortunately, due to Amazon's strict policies, we can't do that. And we did our best to try to share them, but unfortunately, that's not possible at the moment. But that's not the case for my presentation, and this one will be shared after the conference. So again, hello, my name is Andriy. I'm AI technical leader at blackthorn.ai, and I'll talk about how to improve medical image processing using AI. So let's start with the definition. What's medical imaging? And that's probably something you faced a lot of times in real life. It's basically ultrasound, MRI images, mammograms. Everything that can be presented as an image, but in medical domain, can be put into this category of medical imaging. So what's the problem with it? Well, first one is accessibility. With medical imaging, it's usually a lot of times a costly procedure. You have to pay quite a substantial sum. And there is also lack of doctors to read them, to interpret your images. Only 1 in 2 women in US get their mammogram read, according to Stanford Medicine. Second one is interpretation. Training and education of radiologists takes a lot of time and money. And what's more, there is like a huge gap between some radiologist who just started their career and someone who has been in the field for 20 plus years. And we just can't wait 20 years when we need twice the radiologist at the moment. And image reading consistency. Humans make mistakes due to fatigue, some other issues, maybe some problems at home just happened to be at the same time as you have to like get your mammogram read, or maybe you have your ultrasound interpreted. At the same time, there are also problems doctors are facing. Bad image quality, missed area of concern. Like, let's go one by one. Bad image quality. Let's say you just got your ultrasound and then you go to the doctor. Hey, please explain what's here. Am I healthy? Am I or am I not? And the answer may vary, but a lot of times the problem lies that you might not even get an answer and have to do the same imaging procedure again. And that's a huge problem because, especially with high Q, you'll have to wait like a month to redo your imaging. And this is really critical, especially when we talk about cancer and terminal diseases. Another one is missed area of concern. Well, we can do them in a batch, yes. So bad image quality and missed area of concern. Third one is multiple modalities. It's hard to interpret ultrasound and mammograms of the same region. Like, for example, if you want to analyze breast ultrasound and breast mammograms, which is needed a lot of times to make sure that patient is healthy. And it's hard to combine them. And final, there are a lot of images. To make this problem with multiple modalities even harder, you can have like 4 images with mammograms and more than 100 for ultrasound. And to match them to understand that, hey, this one region on mammogram is displayed here in ultrasound, it's quite a challenging task. Also, there are problems clinics are facing. Radiologists are getting increased patient return ratio. So they have to go again and again to see the same doctor, to ask some questions, to make additional imaging, etc. Misdiagnosed patients suffer from false positive biopsy tissue damage. And you can think that this is not a huge problem because, hey, at least you are healthy. But if you think about it, don't know about you, but I don't really like when someone takes samples from my skin, and the biopsy is even more painful. And this highly impacts patient satisfaction. Inconsistent radiologist performance. As I already mentioned, radiologists can just have a bad day. Long diagnosis process. You'll have to, in order to get diagnosed, you'll have to, a lot of times, get ultrasound imaging, which means you'll have to wait like a week, if you're lucky, to get ultrasound done. Then get mammogram done, again, might be another week, maybe 2, maybe even a month in some cases. Then you have to go to your radiologist, ask, hey, what's the spot here? Am I healthy? Am I not? And maybe you'll have to go back to additional imaging. And when you count all this time a patient has spent in a clinic, it will amount to 2, 3, even 4, maybe in some rare cases, half a year time of from first imaging to the diagnosis. And lack of highly experienced doctors. As I already told you, there is like huge gap between novices and expert radiologists, which means that experts are very rare. You'll have to wait, again, 10, 20 years to get from novices to expert. And a lot of times we just can't wait so long. But before we continue, let me just spend a minute and talk about who I am. As I already told you, I'm AI technical leader at Blackthorn. I have over a decade of experience in IT, ranging from small projects to projects for global Fortune 500 companies. I worked with various partners, including some from global Fortune 500 and also FANG, which is Facebook, Amazon, Apple, Netflix, Google. And I'm also teaching machine learning in university. Here you can get my credentials. If you want, feel free to connect with me in LinkedIn or mainly on my mail address. I'll just wait if you want to screenshot this slide and get a super photo. Okay, let's move. And how do we solve all those problems? There are a lot of possible solutions, but one of the solutions I personally worked on and directed was to create an AI imaging diagnosis solution, which will take in patient images and diagnose them, interpret them, and moreover, it will be seamlessly integrated into clinic diagnosis process. This is first page which you'll face when you get to our solution. If you can see that here's like some charts with detected lesions, here's some analysis in progress, and recommendations of what you should do after you've got your images analyzed. And let's just go through quick workflow of solution. You can get your images uploaded here. After they finished, you can start analysis, and in this screen you can see that analysis is in progress. And when it completes, you'll get this slick and small, easy to interpret table with the results. And as we can see, left breast LCC and LMO has a normal, but we detected some benign regions in the right breast. And as you can see, it's not just right breast, it's right breast in both projections. So from the side and from the top. Sorry, I think there are some problems with the presentation. One moment. Let me just click through it. All right. Sorry, presentation wasn't updated. Yeah, and after you got your results, you're able to view them in this like view, mammogram view, we call it. And moreover, you are not just able to like view them, you can interpret them. You don't get just the result that this breast is benign or this breast is cancerous, malignant. You also can see that there are some regions and what are them? What are they? And also on top of it, you get a heat map. And this heat map explains, hey, this region is highly suspicious. I haven't detected, it's not suspicious enough to be classified as benign or malignant tissue. But at the same time, out of all of the breast, this region is the most suspicious. And same can be seen in this on the bottom image. again, that was mammogram, this is ultrasound, right? And you could get, hey, I saw this ultrasound image, and on the left, you can see there are like a lot of malignant parts. And the truth is that almost on each ultrasound image you see here, there is a malignant tissue. For me personally, this sounds like a highly suspicious case. And I, as a patient, can do appropriate actions. Maybe I'll have to speed up my diagnosis. Maybe I can go to additional images, and I don't even have to wait for doctors to diagnose me. I can already do some steps in advance to make sure I will be healthy. And as a result, you'll get like this mammograms, part of images, and ultrasound. You'll get huge list with all your medical images analyzed. Now, but that doesn't look like a seamless integration, right? Because when you have to go get your images, download them yourself as a patient, it's like additional steps you have to do. But that's just one option of integration. Another one is to do a seamless integration with the clinic. And here you can see how it can be done. So this is a slide from RSNA conference, and it just shows a great and simple way to integrate it into clinical diagnosis process. So when you get, first, let's start with EHR. You get an order to do some imaging, right? So patient comes to you and you say, hey, let's put it to EHR, let's fill order, and let's follow to the image taking, to modality, what's called here. It's why it's modality, because there are like different images, right? Ultrasound, mammogram, MRI, CT scans, X-ray, etc. After that, as usual, all of those taken images will be sent to image server. In USA and in Canada, you are required to have them, and you always send them to image server to collect them. And when they are sent to image server, this is the step in which we can integrate AI solution. We can say, hey, new image has come, let's analyze it. And that's what is done. You can go, AI orchestrator detects that there is a new image and sends it to the specific AI algorithm used to integrate this solution into clinic workflow. AI algorithm do the processing, makes their magic done, and then results are sent back to image server. And what's nice about all of it is there is no extra human interaction. When doctor starts to read the exam, he just sees, hey, there is like raw images and there is AI part. Let me just open one here, and I can read them seamlessly. Even more, I can not just read them seamlessly, I can even prioritize which parts, which images should be read first. After that, there may be done some additional steps regarding AI image interpretation, AI image results analyzing, but it's more about improving current AI solution and less about integrating the existing one. And the huge advantage of the solution is that you don't have to actually upgrade your image taking device. You don't have to switch from some Samsung ultrasound to the newer model. You can just use your old and high quality devices and integrate AI part without updating, without spending extra money. And how did we do it? This is an architecture of the solution. We did this with Azure. This is a cloud solution, but with this architecture, it actually can be deployed locally as well. And as long as you have HIPAA compliance, everything should work and will work for you. So what are the results for this specific project or for this specific solution? As a result, we developed a solution which performs better than average radiologist. So remember when I told you that there is a huge gap with novice and expert radiologist. And we are not just beating novices, we are beating even somewhat experienced radiologists. Of course, they're like humans which have spent 20 years in it, and there's probably no way you will beat them soon. But at the same time, that might be even not our goal, because just by acting as an average radiologist, we will be able to improve the quality of decision made even by expert radiologists. You know the saying, you even sometimes need a rubber duck to talk to have to make a better decision. And AI can become this rubber duck to make sure that even expert radiologist doesn't do mistakes. We integrated this solution into the telemedicine solution. So I'm sure you have faced at least once in your time with telemedicine solutions when you can interact with doctors in your country or worldwide and ask them for diagnosis, for some kind of advice, etc. And what's more, in some of them today, you can even ask for AI for opinion. And we are also in the process of onboarding radiologists to the platform. This is a long process because you have to do a lot of culture fitting. You'll have to do a lot of AI education, but we started it and in the process. So overall, how can healthcare benefit from AI imaging? First one is combination of AI and radiologist to make a better decision. The impact is huge. Scientific papers say that even with bad AI, you'll improve the quality of decision almost by 25%. We can speed up reading of highly suspicious mammograms and ultrasound images. So imagine that you have a bunch of images, right? A bunch of patients. And probably some of them are normal images. So normal meaning they don't have any suspicions, being suspicious of cancer. And at the same time, you can operate that, hey, maybe I'll have to read images of highly suspicious cases first. And if you can allow to do that, that might be a good idea to make sure that speed of diagnosis for patients which are likely to have cancer is as small as possible. And third one, you can provide AI explanation to the patient without distracting the radiologist. I just show you this heat map, which can show the suspicious regions, but that's just one part of it. You can actually even use current generative AI to build on top of it and to explain this image as text, or maybe even as voice. Yeah? And this hugely closes the gap between expert AI users and just novices. Maybe just my mom will be able to use AI solution to read her images and make sure that she's healthy. And to end this all, I'm sure you'll have some questions about, is my organization, is my company ready to implement AI. And as we already told you, you get AI readiness checklist. This is just a small version of it. But let's quickly go through it one by one. What types, how can you check if you are ready for the AI and if you can implement it in your company? Data preparedness. This is first one. AI always starts with data. And yes, there are like huge models called foundational models, which don't have to be trained sometimes, but you still have to evaluate, you still have to know how good this solution actually is. And in order to know it, you'll have to need data. So what about data? Data. You might want to audit all data sources and assess access methods, which means that you'll have to make sure your data is protected, and you'll have to make sure that there is no like bad agent which can fake your data, make it gone, etc. Quality. Ensure high quality, consistent data. This is hard one, I know. Data always evolves, business processes always changes, but at the same time, if you can, I'd say that this is probably one of the most important checklists, one of the most important points I want to make. If you just forget everything and remember just one thing from all this AI readiness checklist, make sure that you have a high quality data and it's collected consistently. And address gaps and clean this data if needed. Governance. Establish policies for privacy, security, and compliance. Infrastructure. Ensure scalable infrastructure considering cloud solutions. And as you saw, this is one of the reasons why we went with cloud solution, because the scalability of it just allows us to process huge amounts of data and at the same time making sure we are Azure and HIPAA compliance. Same can be done with AWS, as you just saw it, and with Google Cloud, with GCP. And via signing specific agreements, we make sure that our PHI, personal health information data, will be safe. Next one, infrastructure preparedness. You want to make sure that you have compute power, scalability, integration, and security. This one probably isn't as important as previous part. And this is usually done when you start working on AI. But if you can do some steps in this direction, I'll advise you to do them as soon as possible. Culture preparedness. This is a hard one. You'll have to, and there are like a lot of points why it's hard. Let's just go one by one. Leadership. Secure top management commitment and funding. AI can be done quickly. You can have first results in a couple of months, but the commitment should be long-term. Literacy. Promote AI understanding across all employees. This is hard. And what I even would say is that today, some of the healthcare providers have in their policy not to use ChatGPT or similar solutions to make a diagnosis. It goes to the point when ChatGPT is just banned, right? And can be accessed in the clinic. This is a radical solution, but at the same time, it's sometimes needed to make sure that doctors respond for their solutions, that doctors take responsibility for their diagnosis. Change management. Prepare for workflow changes and potential resistance. When you want to integrate AI, there will be changes made into your business processes and made into your maybe whole clinic operation or whole company operation processes. And innovation, encouraging experimentation and learning from failures you'll highly benefit from it. And if I come back to this solution I've just told you about my AI imaging diagnosis solution, if you listen carefully, I said that radiologists are in the process of onboarding to the platform. And this just shows that culture preparedness is a slow process, and you have to start slowly and share your thoughts about AI, share that we'll have to be prepared for AI in coming years today. And strategic preparedness. Use cases. Define problems AI will solve or may be able to solve, focusing on high value cases. Like, don't just focus on, hey, I want to diagnose this image, and focus more on high level. I want to speed up radiologist workflow. While they are similar and can be done at the same time, they have a slight difference, which will make a huge difference in the end. Talent. Identify skill gaps, train staff, and hire AI experts. This obviously, AI changes every day. It might be hard to get a hang of it and to make sure that your solution you have in your mind is a valid one and will benefit you if you're not an expert in AI. So identifying skill gaps and what kind of talent you might need also will be helpful. Ethics. Develop guidelines for ethical AI use. As I already told you, in some companies, in some clinics, in some healthcare providers, ChatGPT is banned, but it goes beyond ChatGPT. Even with AI imaging solution, you still have to prepare and make sure that each of your personnel knows of AI guidance, knows how to use this AI solution, and to which degree you have to agree with it, and to which degree you can trust it. And ROI, set clear ROI expectation and success metrics. If you'll have problems with any of the steps, just write me in LinkedIn. Maybe I'll be able to help. And continuous learning. It's not enough just to implement AI. You will also have to continuously improve it. You have to learn from feedback, implement continuous feedback to improve AI. Moreover, when you talk about something that patients are not used to, you'll have to think about how to manage expectations, how to make sure that patients understand what is done if your AI solution will be exposed to patients. Stay informed. Keep up with new AI technologies and practices. For example, I'll have to read. I spend every day at least 1 hour reading scientific papers, and this helps me to stay informed in AI field. Partnerships. Form partnerships to accelerate AI initiatives. It's not enough if you want to have a solution quickly, if you want to integrate it quickly, it's usually helpful to have some kind of partner which has an expertise with it. Yeah, and that's all. But to sum it up, AI can help not just to diagnose images, it can help even not giving a strict diagnosis. It can help radiologists by improving their performance. It can help patients by interpreting their results. And it can help clinics by improving speed of diagnosis, by saving, by increasing amount of patients which have done readings by mammograms or ultrasound images, etc. Thank you. Now I think we have some time for questions. Do we have some?
Yes, I think we do, Andrei. Thank you for that comprehensive and enlightening presentation. We'll move on to the Q&A session. Please submit your question in the chat if you haven't submitted already. The first question, I believe, is how is responsible to do the ETL process to so specialized data like the healthcare's data in their platform? If you can answer that, Andrei, that'll be great.
Yeah. Let me just rephrase it a bit. How to manage ETL data responsibly, and how to probably make sure that you are compliant with all the regulations and that your data doesn't get leaked. So, compliance. As I told you already, Azure, AWS, Google Cloud, all of them are HIPAA compliant. So as long as you use them, it's allowed to use them. But there are also a lot of steps which you have to follow to stay compliant. Like you have not to send data to your partners which don't need it. You have to have business association agreement signed. And you have to make sure that you not just protect your data, but also report on data breaches. And about data breaches, let's go to security. With security, there are like huge list what can be done, but at a minimum, as a minimum, there are some third-party solutions which will not just check that your solution are HIPAA compliant, it will also check that it's secure and no data breaches can be done easily. Some of them include things like DOS protection, so your website or your solution won't be down. Another checks that SQL injections won't be done, and as a result, you won't get patient data leaked. I hope I answered it.
Thank you. We also have two more questions. The next one is, what prerequisites are needed to develop an AI-based medical imaging system, and how and can such systems be built without the resources of FANG companies?
Yeah, great question. Let me think just a moment. Yes, those systems can be built without hundreds of billions of dollars, but obviously there is a difference. And main difference lies in two ways. First one is these big companies usually focus on big general solutions, meaning that they might not cover your specific use case, right? So let's say, for example, same ChatGPT, Gemini from Google, Claude from Anthropic, etc. All of them are some foundational models. They're good at conversation, at conversing their thoughts, but they're not good at diagnosing images. And from what we experience with this project, it's already you don't have to have like thousands of billions of dollars to make a good solution which fits your needs. But what will you have to have is a mind that this will help me and help my patients, and probably good AI experts to do that. So to summarize, first one, focus. Big companies don't have this huge focus. Second one is integration. You can actually somewhat integrate and tune up these huge solutions made by one companies and tune them up for your specific use case and use them.
Thank you for
Mikhailo?
your answer. Yeah, we also have another question, is how can AI help minimize doctors' errors and contribute to safer patient care? If you can answer that as well, it would be great.
Yeah, great questions. I love them just because that's some things I wanted to share with you, but thought I might not get into time. So, can you read it again?
Yeah, sure. How can AI help minimize doctors' errors and contribute to safer patient care?
Yeah. So, first one, as with this medical imaging solution, you can, for example, before even going with images to radiologists or to ultrasound experts, you can run these images through a AI medical imaging diagnosis system and filter which images are more suspicious. First. Second, after radiologist or after some another doctor have diagnosed the solution, you can again check that this solution matches with AI, or even more, matching is just not enough. Maybe you'll want to make sure that radiologist, for example, has marked same suspicious regions as your AI system did. And these two ways to make pre-processing, right, before visiting the doctor runs through AI, and after doctor diagnosed your images to run through AI, just these two steps will help to drastically improve the quality of diagnosis, and scientific studies confirms this. And for example, if you have reading by one radiologist, you'll have around 80% quality of the diagnosis. If you have your solution, if you have your image read by two radiologists, you'll get it up to 95%. And if you have this read by an AI, you'll get over 90%, just an AI. But what if you combine AI and radiologist, then you can get to the two radiologists. So you can get a much higher quality of results, much higher quality of diagnosis without spending the time to wait for a second radiologist to read your image. Mikhailo?
Yes, thank you very much. And we have one more question. Can you provide examples of how AI has optimized process in clinics to enhance efficiency?
Yes. Let me just think about which of the cases I can share with you. Yeah. So I think Alex, our next speaker, will be talking about it. But one of the cases is information extraction from patient documents. I will not spoil it, but I think it will be helpful to see the presentation, to see that lecture. But out of it, another one would be automatically processing of scanned documents. And what we did with it, we had there are a lot of documents which are scanned in the clinic, and not all of them are easy to interpret. So you can use AI solutions, convert them to AI readable format, and process them and understand that, hey, this document is for patient Andrei, this document is for his wife, Olia, etc. And after you process them, you can already do some decisions like book a meeting, book a visit, and maybe analyze some images of theirs.
Thank you. Thank you also for your questions and engagement. And we're now heading towards our final session of the day. Our final speaker for today is Alex Gorbich, CEO and founder at blackthorn.ai. Alex will discuss how innovative technologies like VR Healthcare Studio and AI-powered health assistants are transforming the healthcare landscape. He will join us in about a minute.
Hi, everybody. My name is Alex. I'm PhD in AI and CEO and founder of blackthorn.ai. Today, we'll talk about unlocking the power of data in generative AI for healthcare. Our problem that we will talk about today is unstructured data. Unstructured data is as text documents, PDFs, scanned documents like images, I don't know, books, reports, and everything you have in your hard drive and your company object storage. Only 20% statistically are in your database and somehow used by business intelligence so that your C-level can make use of it and it helps in corporate decision-making. Unstructured data, on the other hand, is inconsistent, very hard to automate, and as a result, it is unused, but it contains a lot of information and useful information. So today we'll talk about how to deal with it. Here is a big picture of a solution that we offer to unstructured document data extraction. By unstructured documents, we mean PDFs, doc file, TXT file, charts, graphs, web pages, scanned documents, and with using our proprietary tool, we can convert them to structured data. It can be CSV, JSON, Excel, a database table, any structure that you prefer. So here you can see an example of an Excel file header and JSON with keys and values. Let's briefly review legacy approaches and their struggles. So yeah, the most adopted one is manual. People manually review those files and type the data into a database or anywhere for the data to be used. Of course, it is labor intensive, slow, and as a result, expensive. Document parsing. By document parsing, we mean, first of all, only TXT and doc, sometimes Excel files. Anything that we can read with something like pandas and other things where we can touch this text. The drawbacks are, first of all, this is only textual data. Second, we have to invent fragile parsing rules, and they are not universal. For every document type or a set of documents, you have to reinvent the wheel. You have to develop new parsing rules. As a result, it's a high development effort. As a result, it's expensive. For scanned documents, there is a long time we see OCR. Yeah, everybody who worked with OCR knows that it makes mistakes. So the best you can expect is some kind of accuracy for typical documents, And for another type of documents, you need another OCR. You have to fine-tune these models, and whatever you try, you still have context issues, and you have to map those fields. It's another difficulty, and it is not universal. It is a high development effort. As a result, it is expensive. But recently, I think you all know that we got a technological breakthrough, and the name of this technological breakthrough is LLMs, large language models. You saw, and we all know that we have AI, the subfield of AI machine learning, and the subfield of machine learning is deep learning. So recently, this classification system evolved, and now we have a specific field inside deep learning. It's called generative artificial intelligence, or Gen AI, been on hype past year since ChatGPT appeared. And inside here, the most popular technology adopted is large language models. And as you might guess, we utilized it to develop this tool. So this modern solution is made of LLM and something that is called RAG, or Retrieval Augmented Generation. And this tool allows, actually it's a vector database with the LLM. It allows to guide LLM and use knowledge sources to navigate through the context and make the information retrieval more information completed. Its benefits are reduced development efforts. Yet you don't have to reinvent the wheel for every type of the document. Usually you tune it to some set of documents, like a few hundred, and then it works for the rest. It's very easy to adapt to different layouts, and you don't have to map information, etc., etc. Yeah, of course, there are some challenges like hallucinations, like issues with data privacy and intensive resource use, but they are addressable. The summary of this is this approach is a way cheaper than the legacy approaches. Now I will briefly describe the technology behind. So there are two steps. First is indexation of documents, where the collated unstructured data, such as plain text files, PDFs, texts, Excel spreadsheets, Markdown files, HTML files, other files like images. For images, of course, we need to use cross-modality LLMs like visual LLMs, which allow extract information from images. Then we extract text or extract information. We clean, normalize the information, we chunk it and turn into embeddings and put embeddings into the vector database. This is step one. Step two is actually information retrieval. This vector database that was created on step one, we use in a combination with the queries that we submit to LLM. So instead the query going directly into LLM, it first goes to vector database, finds the most relevant embedding that is the most similar to the query context, and then combines the prompt with this piece of document and submits it to LLM so that the output has no hallucination, it's grounded, and discovered the document, information from documents. You can learn more about LLMs, RAG, and custom data in our blog post following this link or scanning this QR code. To summarize, the benefits is less time, less people, like cheaper solution, improved detectability, also context taken into account. Like briefly, it's 10 times reduction in development time and cost. Now I will talk about several use cases that we already met and deployed the tool. First is extracting data from web pages. Here is an example of a web page. And there are hundreds and thousands of web pages with this information. And we don't know where on each of these web pages this information is located. We only want to know like name, scientific title, surname, address, and a field of a specialization of doctors in this case. And we want to automate that. Imagine writing a scraper, web scraper for each of the web pages. You will need to develop a custom web scraper, and that will take you eternity for thousands of web sources. And then they will start to update websites, your scrapers will crash, and you will have to fix them. And that will take another eternity to maintain your tool. Like AI with LLMs is free of that, so kind of faster and cheaper. Another case study is retrieval information from scanned patient cards. Here you can see the scanned patient cards. It's blurry a little bit, and also there is some rotation. But what we want to know what kind of procedure was applied to a patient and what is the clinical history requested. And we can extract that and map to a patient's gender and other features into the database. And then we have this information collected, we can work with it. We have a client basis and who did what and when, and all the stuff that is needed for doctors. So the third case is insurance information retrieval from PDFs. So an insurance company has a tons of PDFs where they applied propose something or reports on their customers, and with using the tool, we retrieve like client rating, what type of product was offered, language, in which state, programs, and other things. You can see it's automatic. The fourth case is extract information from educational technology PDFs. So we have people that undergo or apply for a study in a particular like school or university, and then they have education program records where they have name, number, and also features of a student. And these documents differ in structure, and content is more or less the same. Sometimes some pieces of context are missing, and we also want to handle that. The point is that the tool is universal for any structure of documents. And see here, we want to have a particular results independent on the document structure and stuff. And see how the tool collects information. The fifth use case is automation of reviewing scientific papers using web resources. The goal here is to make easier life of reviewers. So they submit a query like, hey, I want trials of Pseudomonas aeruginosa bacteremia. And the tool first goes to internet and find the relevant trials, and then extracts a quick summary of the information in trials. Of course, this is just a piece of information. There will be more specific information on which medical substances were studied. Is it a penicillin? Is it other antibiotics and stuff? Because this is the most area of interest, and it can be extracted automatically. The sixth and the last case will be extraction of information from charts and graphs. You can see the conceptual schema idea here. So you have graphs, but you want to turn them back to a table with data, and the tool allows that. So thank you for your attention. Feel free to ask questions. I will be happy to answer. Mikhailo?
Thank you, Alex. Thank you for that visionary presentation. The potential of generative AI in healthcare is truly inspiring. So yeah, let's take some time for the last Q&A session. The first question is how generative AI differs from traditional data processing methods in handling unstructured data.
So I gave you the case of websites. By the way, first, it differs from case to case. The easiest case to give you a taste of the difference is web page scraping. Typical, the most adopted web scraping now is using tools like Selenium, where a scraper emulates a user actions. It goes to HTML and CSS code of the page and tries to extract information using a hard coded structure of a website. So first you need to code it using explicit rules, and then you will get information if this information remains in the static places. If the structure of the web pages change, or you need to extract information from another web page, you need to write another web scraper. If you have 1,000 web pages, you need to write 1,000 web scrapers. Yeah, do you feel effort? Brief estimate is like 1 day for one scraper, right? So you need 1,000 days for 1,000 websites. Using generative AI and our approach, this time will be reduced like 10, maybe 50 times. So you will need 150 days, something like that.
Great answer. And also we have a question, how does AI ensure unbiased and immediate diagnosis, and what impact does this have on patient care?
Can you repeat, please?
Sure. So how does AI ensure unbiased and immediate diagnosis, and what impact does this have on the patient care?
I think this is a question to Andrei. How we make sure that the AI is unbiased by referencing with human specialists, unfortunately, or we use another AI to validate the first AI. But yeah, you might guess the risks. Yeah, who promised and who can guarantee that the second AI is not biased? And unfortunately, all AI is biased. All of them wrong, but some of them useful. So yes, to make sure that the AI is unbiased, it undergoes trials under human supervision. Trials, then you collect user feedback where they say, okay, it was correct, it was incorrect. For some time, it is maturating, where you take into account bad cases and you like close these corner cases. And with some time, this solution has like 99.9 accuracy percent. To achieve 100%, you just need to say it, okay, I don't know, in some cases with a low confidence. Yeah, in this way, we can achieve almost perfect accuracy. But I would not take the responsibility to say that it will be always correct.
Definitely. And the last question is asking, so Gen AI approaches do not require development of such rules as older approaches?
No. It requires chunking information correctly. It requires some observation. It requires some tuning. But the major advantage is that you do not develop the rules. This is a top one advantage, and it saves like, I don't know, weeks, months, years, you tell me.
Thank you for an answer, and thank you guys for your questions and engagement. Our time is coming to an end. Thank you everyone for joining us today, and we hope you found the sessions informative and inspiring. We'll send you a recording of the event and additional materials via email. Also, don't forget about the special deals we mentioned earlier. You have the opportunity to benefit from the exclusive offers, including a 10% discount on creating your own AI product and a free AI integration readiness checklist. To get it, you have to go to blackthorn.ai/contact, fill in the form with your goals, and add the promo code AI10. See you at future events, and have a great day.
Thank you everybody for attending.